Remember, regioselectivity is referring to where something goes. We talked about regioselectivity a lot in our addition reactions last quarter, adding things to alkenes. So in regioselectivity, we're going to be talking about, in the free radical reaction, where the halogen goes on the alkane that we're reacting with. We're halogenating. And we're going to be talking about bromine and chlorine because those are the only two halogens that are reasonable to use in a halogenation process. We're going to first talk about bromine. Because bromine is the most controllable halogen in terms of free radical reactions, the radical reactions involving bromine will proceed via the most stable radical. The most stable radical is the one that's most substituted. And here we're talking about not the bromine radical, but the alkyl radical that is also involved in the reaction. If you remember back from section 11.3, there are the alkyl radicals that are involved in these processes, and there's a few different types of them. So the bromination process is going to favor the pathway that involves the most stable alkyl radical, and if you remember back from the day before yesterday, the most stable radical is the one that is the most substituted. So we're going to look at some examples of that in just a second, but before we do that, we're going to talk about chlorine. Because the chlorine is a very unstable radical, not controllable, we're going to make all possible products, just as we saw in 11.3. So everything is going to happen. We're going to get a huge mixture of a whole bunch of different types of halogenation products. But still, within that jumble of a mixture of products, the product that is formed via the most stable alkyl radical is going to be the major product. When you're predicting the products of these reactions, the chlorination and bromination reactions, when you're doing bromination, you're going to draw the product that comes from the most stable alkyl radical. For example, the free radical halogenation of propane. If we want to predict the product of this reaction, we're going to consider all of the different types of alkyl radicals that will be formed during the propagation steps of this reaction. We can abstract a hydrogen from the end of the chain, put a radical on a lone electron on the end of the chain. That would be a primary radical. Or we could do it from the other end. That's going to be exactly the same. Or we can abstract a hydrogen and form a radical by putting a single electron on the center atom. That would be a secondary radical. That's clearly the more stable radical. So the product of this reaction is exclusively 2-bromopropane. We'll probably make a small amount of 1-bromopropane, but it's not enough for us to bother writing it down. So this is the only product that you're going to write down. You're not going to write this one down at all, because whatever you make, whatever quantity of this you make, it's trace amount compared to what you make over here. Now with the chlorination, remember we're going to make everything. So we're going to chlorinate on the center carbon. We're also going to chlorinate on the end carbon. And we're going to make a large enough quantity of both of these products that we need to write both of them down. We can say that this one is going to be the major product because it's formed from secondary alkyl radical, and this one's going to be the minor product. Even though it's the minor product, there's going to be enough of it there that it's important for us to write it down on our list of products. So with bromination, we only write down one product. And with chlorination, we write down every single product, and then go back and indicate which one is the major product. So for this bromination, we want to consider all the different places where the bromine could go. We've got this end carbon right here. If we had an alkyl radical there or here, those are equivalent sites. That would be primary. We've got another primary spot over here. We've got a secondary carbon right there and a tertiary carbon right there. That tertiary carbon is the one that's the most stable. That's where bromination will take place. That's the product that we get out of this reaction. We're not going to draw any other product because the other ones are not going to be present in large enough amounts. With chlorination, that's a different story. With chlorination, we want to draw all the products. We'll chlorinate at the end, which is the same as doing it down here, so we don't need to draw that one twice. And we'll chlorinate on that tertiary carbon in the middle, and the secondary carbon, and the other carbon at the end of the chain, this one, because it halogenated on the tertiary carbon, that's the one that's the major product, the one that's formed in the greatest amount. All the others are minor. Let's do a couple more. When you're doing these with bromination, with chlorination, you just draw every product. Put the chlorine everywhere, draw one of each. With the bromination, one of the strategies that you want to take is just to go through and say, remember the order of stability of the radicals. Ask yourself, do I have a tertiary radical? Actually, you should ask yourself, do I have a benzyl or an allylic radical? No, we don't. Then do I have a tertiary radical? Or excuse me, tertiary carbon? Yeah, right here is a tertiary carbon. So that's where the halogenation will take place. So basically you're going to go backwards down the chart of stability. You're going to look at the most stable radical, that's the benzylic. If you can't find any benzylic carbons, look for an allylic carbon. If you can't find any allylic carbons, look for a tertiary carbon. If you can't find any tertiary carbons, look for secondary. If you can't find any secondary, then put it on a primary carbon. With chlorination, it has to go everywhere. And with this particular molecule, we're going to have a lot of different products. This one will be the major product because that's got the chlorine going on to the tertiary carbon. One, two, three, four, five, six.